This is problem 3 on the manipulating vectors with trigonometry worksheet. An electric charge is placed at some point in a plane. As a result, the electric field at the origin is 44,000 newtons per coulomb in the positive x direction. We'll put a second charge there. Now the electric field is 30,000 newtons per coulomb, 30 degrees above the negative x-axis. Now the first charge is removed. What is the field at the origin of the coordinate system? Yikes. Well, let's take it slow. Draw a good diagram. Here's charge 1. There's charge 1 plus charge 2. Let's label them. Charge 1, both charges. Now we're going to break the 30,000 newtons per coulomb into x and y component. In the x direction, it's negative. We want cosine 30. We want the adjacent side. It's about 26 in the negative direction. In the y direction, it's positive 30,000 sine 30. That's 15,000 up. We're going to replace these with the components. Get rid of that. Use that. 26,000 that way, 15,000 up. Now we have to think. What the heck is going on here? There's charge 1. There's charge 1 plus 2. We want to know what charge 2 is by itself. And it's a vector sum. Electric field is a vector. What's the field at the origin if the first charge is removed? We need the electric field produced by the second charge at the origin. In the x direction, we do one direction at a time. The electric field produced by the first charge is 44,000. I put another charge there, and it's now minus 26,000. Pause and think. What's the horizontal component of the electric field from the second charge? What must it be? It's got to be minus 70,000. So if you want to use an equation, E1x plus E2x is E total x. And we know E total and we know E1. So E2 must be minus 70,000. Now we'll do the y direction, which is a little bit easier because charge 1 doesn't do anything in the y direction. We add charge 2 and all of a sudden there's a 15,000 Newton per coulomb electric field upwards. It's got to be from the second charge. So E2 in the y direction is 15,000. So now we have the components. We can get the vector. The magnitude is e sub x squared plus e sub y squared square root. It's about 71.6 newtons per coulomb. Kilonewtons per coulomb. The direction, if you use arctangent, 12 degrees above the negative x-axis. So here's a diagram that shows each field. Here's E1. Here's E2. There's E1 plus E2. Should make sense. So the answer is 71,600 newtons per coulomb, 12 degrees above the negative x-axis. That's problem 3.